Hello friends, we will learn about projectile motion today. The path traced by a ball when we throw it into air by making it an angle, some angle theta, says theta from the ground, is called projectile motion. When we jump into the river, we follow a projectile path, it's also called projectile motion. And there are many such processes we do in our daily life which we trace the same path of projectile. Projectile path is actually parabolic. We will see in the given figure. Okay, let's say it's x-axis and this is our y-axis. Now a ball is thrown from here to here, it lands on the ground, this place. Now the ball makes an angle theta, let's say theta with the horizontal axis, that means with the ground. Okay, now we will resolve this, let's say it's v velocity thrown with a velocity v. This is a 2D motion and it's sometimes very difficult to solve the problems of this 2D motion, so we will learn how to convert this 2D motion into simpler 1D motion and solve the complex problems even. So let's start. This velocity v is resolved into two components. In x and y, by vector resolution, we will have in x-axis and this axis we will resolve and will have v cos theta, and in y-axis we will have v sin theta. Okay, now suppose this is the ball. Okay, this is the ball or some, and it is thrown making an angle, some theta angle with the ground, and it will go like this and land it here. Okay, the path followed by this ball is, let's say this is the path followed in xy plane. Okay, and this is the path followed by the ball. Okay, now we have to find the time of flight, the distance, it is called range sometimes, range, this is the range the ball has reached to the place, and the maximum height. Suppose the ball has reached, look, the ball is thrown like this, the ball is thrown like this. Okay, the ball is thrown like this in xy plane, and this is the maximum height. So this is the maximum height the ball has reached. If it is thrown like this, this is the maximum height the ball has reached. Okay, so we will find time of flight, range, and maximum height the ball has attained. Okay, so let's start. For finding the time period, it is called time of flight. Okay, so how we will find time of flight? Okay, the ball, when the ball is thrown like this in this manner, stand here. Okay, and look, the ball is going from this to this. First of all, the ball is reaching to the top. Okay, and it will take the same time to come down to the bottom. Okay, now in this plane we will see the ball is going up and then down. Okay, when we will stand here and look, the ball is coming from here to here, we will see that ball is going up first and then going down. Okay, now this is how we will convert the 2D motion of the ball into 1D motion. So what we will do, we will apply equation of motion in this. Okay, so for this we know that for time period we know the equation of motion, v is equal to u plus at. Okay, now the ball, when the ball has reached to the top, okay, when the ball has reached to the top, the velocity, final velocity becomes 0, and okay, and initial velocity is what? Initial velocity is u sin theta, because we are noticing it in this plane. Okay, and this is y x plane. Okay, look, this, the ball is going up with velocity, this is the ball going up. We will resolve this in y-axis. The ball is going up with v sine theta, okay, v sine theta, and acceleration due to gravity will act downward, g will act downward, so with minus sign, and t here is time of flight, so we will get t is equal to u sine theta by g. Okay, now the ball is going up, then it will also come down, so it will take twice the time of this, so time of flight will be 2 times this, let's say small t is equal to t is equal to 2 u sine theta by g. Okay, now we will find range. That means the distance, this distance is called as range. Let's say it's r. Okay, ball coming here to here and then lands here, then this distance is called range. Okay, fine. For range, when you will look from here above, when you will look from the top of the ball will go like this, and when you're sitting at the top and looking at it, what you will see that the ball simply is going like this. When you are sitting at the very top, you will see that the ball, although the ball moves like this, but what you will see, the ball goes like this simply. So for this, what we will have to do, this is called range, and for this we require two things. What two things? First, this is simply distance, and we know that distance is equal to speed into time. We need speed and time of flight. So what is speed in this x-axis, this horizontal direction? What is its speed? Its speed is u cos theta, okay, into time of flight. Okay, so range is equal to u cos theta into time of flight, and it is 2u sine theta by g. Okay, and by rearranging this, what we will get, u square into 2 sine theta cos theta divided by g, and this will be equal to u square sine 2 theta divided by g. Okay, now third, the maximum height the ball has reached to. Okay, let's say it's h. Now again, applying equation of motion, we know that equation of motion, v square is equal to u square plus 2as, and when the ball will reach its maximum height, then its velocity will be 0, and u will be equal to u sine theta. Okay, and acceleration due to gravity will be minus g, minus sign. Why? Because always gravity, acceleration due to gravity acts in downward direction, so 2g, and h is the maximum height we are to find. And rearranging this equation, we get that h max is equal to u square sine square theta by 2g. This is the maximum height the ball will reach up to. Thank you.